Hi everyone, welcome back to day 13 of Advent of Code. Today's challenge is called Claw Contraption. So in our challenge today we have equations, which is something I'm going to enjoy a lot. So we are trying to play one of those arcade games where we use the claw to pick up a toy, and that's what we're doing here. I don't like those because they are scam, but in this case we actually have a way to win, because we have these equations, and if we get the right equations we can win the prizes with the least cost. So we have these buttons A and B. We use these buttons to press and bring the claw to the right position, and each button has a cost. So it's not our usual claw machine where we just insert the token once. Here, every time you press a button, a number of tokens are used. So the A button costs 3 tokens to push, and the B button, it costs 1 token. So we have to find how we can get the prize with the least tokens. So here they've given us an example of 4 such situations. In the first one, you have to line these up in such a way that you by pressing A some number of times and then B some number of times, you should be able to reach this position. So these are basically equations in 2 variables. It'll be 94x plus 22y is equal to 8400, and 34x plus 67y is equal to 5400, and we have multiple of these. They've told us here that the easiest way, they've explained to us here that in the first case, if we press A, then in the x-axis it would move 94 units, and along the y-axis it would move 34 units. And so if we press B, it'll move 22 units in the x-axis and 67 units in the y-axis. And if we do that perfectly 80 number of times for button A and 40 number of times for button B, we will reach the point where the prize is. For the second equation and the fourth equation, there are no solutions, so this is what our machines work on, I think, in our arcades. And then for this one, for this equation, we have a solution. If we press the button A 38 times and B 86 times. Okay, but doing this will cost 2200 tokens. We have to just add them up based on the number of tokens. But because if we have a slope for any line, they will intersect at one point or infinite points or no points. So I remember something like that where we could find this to easily determine if there are anything. But here we also have to consider that we are going to be moving in 1 unit, and there cannot be a fractional unit. Like we cannot press A 0.5 times. So that is another thing to consider. I have an idea of how to solve it. We have to ultimately sum up the number of tokens that it costs us to get the prize, and that will be our answer. They've also told us that no individual button will have to be pressed more than 100 times. So what are the fewest tokens we would need to have to spend and win all the possible prizes? Let's find that out. Okay, so we've got the solution to our problem so far. So we're getting 480 as per the sample input's expected output. So I'll explain the code now. So we're first processing the input. This is a little more involved as compared to all of ours so far. So what we're doing is we're cleaning up the string so that first when we get this kind of an input, let's just consider this part. We're removing all these extra characters which we don't want, x plus y plus x equal to y equal to. Then we are removing this part. We're replacing all of that, and then we are splitting it because each of these problems are separated by a double next line character. Then for each in each of them, each one of these form one part of the equation, so we're splitting that, and then we are removing this first part which is telling us about the button and the price and all that, and finally we are mapping it to a number. So what we get is okay, let me show that. So what we get is something like this. Now we use this in our find total tokens, where we keep track of the total tokens that we have found so far, cost of the token A and cost of the token B, and hard limit for the button. They've told us it's 100. Then we form these equations and we find the maximum intercept that can be found for x and y. So for the first equation, so it forms 94x plus 22y is 8400. So for that, if y was 0, we would get 8400 by 94. So that will be the maximum possible value of x. Similarly for x2, and for y, if x was 0, what would we get? That would be the maximum possible value of y. So that we can reduce it even beyond like even before 100, which is the hard limit here. And we're checking the minimum of the three of them, y1, y2, and the hard button limit, because both of these equations should have a solution when we get when we get the price. So now we are running a loop where we are keeping x as the maximum value and y as the minimum value, and we are slowly increasing one and decreasing the other. If the result becomes greater than what we want from forming the solution of the equation, then we will reduce x because that is a greater value right now. Otherwise we will increase y, and if it is exactly equal, then we will break and we will keep track of what the token cost was. And so we're getting this. To explain this better, I think there is a way to do that. So here, if you remember, the first equation was, and our second equation was, so we're getting an intersection at this point, which is 80-40, and I'm checking what the maximum intercept values were. One will be 0 and the other one will always be something else, which in our case is 158. Similarly for the first equation, it would be 89 and 0. So we are checking in this region. We will go to the maximum of this and this. So that's how we have limited our space. Now let's check for the actual input what we get. Okay, now let's verify if our logic is right. Awesome, we got it. Now let's see what part 2 is. Okay, in part 2 there's not much that has changed, except our answer is way huger now. We don't have the limit of 100 presses anymore. So the result is actually whatever this number is greater than whatever was originally given to us. So we just have to add that. By the use of our equations, I don't think we will find it this way because we were still looping a lot. But let's see now. let me explain what we've done. This process input is the same. In find tokens, we are adding this error which they made, and then these are the two equations we formed from which we are getting the values of y and x. Now, because JavaScript uses a weird way to calculate, we get some errors even in certain values. So like, let me show you. Let's see this for the dummy input without these things. So now we get something like 40.0000 something 1. So this will cause us issues. So what we can do is truncate it to this point and then consider it. So 2 decimal points will be there. So what we get after that is something like that. So this becomes, so this becomes 40, this becomes 80, this becomes 135.40, etc. And then when we come to this, if we do x modulo 1, if there's anything on the floating point side, that will become the remainder, so it will not be 0, and so we can get the only ones that we need. That's how this is done. And now I've added too many locks and it's very dirty, so let me remove those and comment this one out. Okay, let's see what this gets us. Oops, this is a dummy. This is the actual input. So let's see what this gets us. Oh my god. Alright, so I think this whole time pass was because JavaScript's decimal system is the worst, but I love it anyway, so what can I do? Anyway, so this was fun. We figured out something even in JavaScript when we face so much difficulty, but yeah, we got it. It's okay. Okay, now for the equation, how did we get these? So this was my idea behind it. We have something like, so now we can get our x like this. X is c1 minus b1y by a1. So this is what we got there, and so y will become, we'll have to put the value of x into this. So this implies we'll get something like a2c1 by a1 equal to c2. So now let's go here. So this makes it y is equal to c2 minus, we'll take this thing, a2 c1 by a1, and we'll take y common between these two. So we'll get by b2 minus b1 by a1, and you can simplify this a little more by making this a1 c1 and then cancelling this a1 b2. So this gets removed, and this is your y and this is your x. So you can substitute these and get your value. Cool. See you again in the next one. Bye.